Tamil Nadu and Delhi. She has completed her undergraduate and postgraduate in aeronautical engineering from NIET Coimbatore. She is pursuing her PhD under drone domain from Karunia University, Coimbatore. She is serving as a nodal center coordinator for ISRO IARS outreach program, drone trade. She is also a certified drone instructor, DGCI certified drone instructor and pilot for small category. She is serving as a director academics for Aeronautical Sector Skill Council, also an NAC NBA advisory committee for Nehru Group of Institution. She has acted as a resource person for more than 35 faculty development programs, 59 skill development program, and guided 13 research projects funded by government of Tamil Nadu and Kerala through various center of excellences. The most important part is she has trained more than 3,000 students in drone technology, nano satellites, and so many other areas. And she has also received a patent for face recognition drone. Thank you, ma'am. We are indeed very happy to have you for this session. It is over to you, ma'am.
So very good evening to everyone. Thank you, sir, for the welcome. And I especially thank the Department of Aeronautical Engineering, Hindustan College of Engineering and Technology for inviting me to this FDP. And my hearty congratulations to you for organizing such eye-opening sessions to the faculty members in the state of Tamil Nadu and many more states. So as he introduced, I'm Kritika, CEO of Hicet Aerospace Drone Manufacturing Hub, Global Drone Hub, and I'm also the head of Innovation Center at Drone Technology Park in IIT Delhi Sonipat campus. So I'll just get inside our session today. I'll give a small introduction about our company, and then we'll just move on to the technical session, which we are looking forward. So I request the participant, somebody's mic is on, so please check and mute it. Gopinath, yes, thank you.
We'll take
So,
care of it. We'll take it.
yes, so I hope my screen is visible to everybody.
Yes, ma'am, it is visible.
Thank you. So we are Hicet Aerospace Drone Manufacturing Hub. Our branch offices, we are working at Innovation Center in Drone Technology Park at IIT Delhi Sonipat campus, which is in Haryana. And we have collaborated with IIT Palakkad for our drone pilot licensing school, which is DGCA approved. And we have our Technology Development Center, NIT Silchar, and Drone Research Lab at PSG, Coimbatore. And we also have a Skill Development Center at Palakkad. So our this is my contact details. If any of you would like to contact me, you can please note it down. And so the facilities, glimpse of facilities, which I told you. So this is our office at DTP, Drone Technology Park. So we have collaborated with IHFC, the Technology Innovation Hub of IIT Delhi, which is under Department of Science and Technology, Ministry of Science and Technology, Government of India. So the hub's activities to incubate startups, and they have research and development, many other product development programs. So we have collaborated with them as industry partner for the establishment of this innovation center and drone technology park at the IIT Delhi Saneksha campus. So for past 2 years, we are collaborated and we are running successfully. And this is our glimpse of the drone pilot training school, which is awaiting approval from DGCA, and it is at IIT Palakkad. So we have collaboration with the Technology Innovation Foundation of IIT Palakkad. And we have established our PSG Drone Research Lab at PSG Group of Institutions. And our Technology Development Center, we are awaiting at NIT Silchar, and our Aviation Research Center at Palakkad. So, about our company, apart from the branch offices, we have 17 center of excellences with many universities and colleges throughout India, and more than 75 institutions. We have collaboration for skill development, technology transfer, research and development, and also for placement and internship support. And we have trained more than 10,000 students like every year. And we have like three more centers in Kerala itself. Our team size is 130. So apart from Jet Aerospace, we also have four more sister concerns, and we have have around 22 clubs at various colleges throughout India. So our staff members all are aeronautical aerospace background, and they are like PhD and master degree holders, and of course DGCA certified remote pilots and instructors. So our work profile is we basically are into research and development. So we work with this innovation hubs which I mentioned, and also with companies for identifying their program, their requirement, and also creating some solutions for the industrial problems that they are having. With the help of the funds and support from the technology innovation hubs, and we do skill development programs for right from any private educational institution to government bodies. Under various schemes we are providing skill development program, and we also do outsourcing. We develop drones. We set up center of excellences in educational institutions, and we also supply equipment which is for drone testing and other purposes for the drone technology field. Mainly we are a business to government organization. So these are our prominent partnered institutions. So we have collaboration with the Technology Hub, VIT Chennai, SRM Chennai, Satyabama, Anna University also we have collaboration, Nehru Group of Institutions in Tamil Nadu, Kerala, many other universities, Sharda University, Agra. So all these are educational institutions who we have collaboration with already. So our ongoing research work is we are working with the TIH of IIT Delhi and L&T Infra and Defense. So basically, it is for a autonomous paint spraying drone. So this is being funded by the hub, and we will be partially funded by L&T also. So they came up with this problem statement, and we are developing the solution for them. So we successfully tested it in their Chennai location base, and we are working on manned eVTOL, which is part of advanced air mobility and unmanned traffic management system also. The payload capacity we are trying is 400 kg of quad configuration along with the Aeronautical Sector Skill Council. And we also have a project where we are working on our indigenous ground control station. So a portable ground control station that can support the open source ground control station softwares, and which is having a range of about 100 kilometers that can be utilized for logistics, many other industries. That is the main idea behind the research work. So some of our skill development projects. So we are working with the Technology Innovation Hub of IIT Delhi under DST for nurture program. So we trained around like 25 to 30 colleges and around 2,000 students last year. So they all belong to lesser privileged category. So it's like technologically developing the people who are who require this technology. So that's what we tried with them. And this is the drone technology boot camps, which we have conducted at NIT Silchar. So, which is part of capacity building program of Ministry of Electronics and Information Technology. And we also work with Tamil Nadu Skill Development Corporation. We are part of Non Mudal One program. So last year we conducted training for around 8,000 students along with this TNSTC body at various colleges, around 145 to 150 colleges in Tamil Nadu. So we are also working with Kerala's Department of Public Education. So they are establishing drone skill development centers throughout Kerala states in government schools. So we have supported their COE, that is Center of Excellence for Drones, for this drone service technician trade. So we have established this in one of the school, and we are just expanding the same throughout Kerala. So now that's about our company, and now we are just getting inside the topic for today. So even though I was allotted the topic guidance, navigation, and control system, I would like to just give a introduction. And as instructor, it is my duty to also talk about the drone rules to be followed, and we'll also get inside this guidance and navigation system. So I'm just giving a differentiation between unmanned aerial vehicle and drones here. So UAV stands for unmanned aerial vehicle, and it operates without any human beings on board. So there won't be anybody inside this vehicle, and it is flying. Therefore, we call it unmanned aerial vehicle. So drone is also a type of unmanned aerial vehicle, but it will be autonomous. It will be capable of doing a certain task which does not require the intervention of any pilot or human. So that's what we define as drone. And we have given three pictures like a VTOL UAV, a multi-rotor, and a fixed-wing UAV for understanding their different terminologies. So RC plane or fixed wing UAV is a UAV which looks like aircraft, which works like aircraft, which follows the aerodynamics like a real-time aircraft. It's remotely controlled. And the term UAV is generally representing any aerial vehicle which is flying in air without human beings. And of course, drones are capable of working with certain autonomous features. So that's the key difference between three terminologies that we are using. And there is also a term called UAS, which is unmanned aircraft system. So the unmanned aircraft system basically works for collecting the data and processing the data and transporting the data. So how do we call an unmanned aircraft system, or what is an unmanned aircraft system? We are just talking about both the control as well as the unmanned aerial vehicle together as unmanned aircraft system here. So you will have a ground control station at ground, and the vehicle will be flying in air. So the collection of data, processing of data, and transporting the data to the ground control station will be the work of this unmanned aircraft system. So some glimpse on the drone rules that needs to be followed. So these rules are laid by the Ministry of Civil Aviation, particularly the Director General of Civil Aviation. So basically, we classify the drones based on their weight. And here we have talked about nano drones, which is less than or equal to 250 grams of weight. And the micro drone weighs between 250 grams to 2 kilograms. So you have small class. So small class means that it is weighing between 2 kilogram to 25 kilogram. And we have medium class where your drone weighs between 25 kilogram to 150 kilogram. And my large class is your drone will weigh more than 150 kilogram. So this is the classes, and we classify the UAVs into three categories, which is aeroplane, rotorcraft, and autonomous. So hybrid, sorry. So the aeroplane refers to your fixed wing UAV, rotorcraft refers to your multi-rotors that we are using, and the hybrid refers to the hybrid VTOLs that we are using. So these are the categories and classes you have. So based on the classes of your drone or category of your drone, you have certain limitations of using them in India. So, for example, if we take nano class drones, so this nano class drones doesn't require any kind of permission or type certification for flying them. So it can be like used even for research, academic, some of the commercial purposes also. Even the same is applicable for micro, but your small, medium, large drones, whenever it needs to be flown, then they need to be having a unique identification number, which you will get once you register your drone to DGCA. And also, the person who's flying these drones should possess a valid drone pilot license. And if it is being used for commercial purposes, it needs to be type certified. And whenever you fly the drones, you need to get permission from the Digital Sky platform or DGCA. So only then, whatever operations you are doing with your drone is legally permitted in India. And then we categorize our airspace into three ways, which is red zone, yellow zone, and green zone. So the airspace which is called as red zone, is basically the zone where operation of your UAVs and drones is restricted. So if at all it is for any government purpose or valid purpose, then you need to take permission from the central government for operating your drones in this particular zone. And when it is yellow zone, like you can get permission from the airport authority and the body, whoever has imposed this zone in your locality, and you can take permission from the DGC and you can fly the drone. So that will be my yellow zone. And when it is green zone, you are free to fly it just by getting permission from DGCA. Like that is your green zone. So all this zones or the maximum ceiling of operation as per the permission given by DGCA is 400 feet as of now. So this will vary depending on the zones. Even if you are near airport, you are at an industrial corridor. So it is really, emphasized by the government to look at this airspace map, which is given in Digital Sky platform, to know whether your location falls under red zone, yellow zone, or green zone for obtaining proper permission. So all of you, whoever uses drone, are requested to do that. So of course, unique identification number is as per the type of your drone and whatever purpose you're going to use it, whether it is a commercial purpose or non-commercial purpose, you register your drone with DGCA and you get a unique identification for the drone. Even I said that nano drones are exempted from getting any license for flying. Only license and the location permission is exempted. We are supposed to register even a nano drone and get the unique identification number. So that's the thing which is imposed by Government of India. So this slide is just talking about the parts of multi-rotor. So multi-rotor is nothing but a drone or a UAV which is having multiple rotors. That's what we call as multi-rotor. So now the parts that we are going to discuss about is your flight controller. So flight controller is the device which is acting like brain of your drone or UAV, and that will be the main controlling component of your drone. So all your components in drone will be connected to flight controller only. So that's the primary part of a drone. And we have telemetry data. So telemetry data is like a module which is used for transmitting your drone data to ground. So whatever drone data like your speed, your altitude, your location, everything, all the data is given to ground wirelessly through telemetry data. So it's a module which is connected aerially to flight controller, and you have a ground module which will be connected to the ground control station software. So by communication between these two modules, you will be able to see the live drone data on ground. And then you have GPS module. So there are two GPS modules. Of course, we know that GPS is for tracking and navigation purpose, for understanding the location of your drone. And you have platform, which is nothing but the body or frame of your drone, where you mount all the components of the drone. And then you have gimbal and camera. So we are talking about the imaging system, whatever you have attached. Gimbal is a mechanism that gives you movement and control over this imaging system. So that is my gimbal system. And they are of different axes, like it is free to move for 2 axis, 3 axis, 360 degree. So depending on our requirement and application, we can select the gimbal system. So now, apart from that, we have the ground control station software. So this is the software which is used for, tracking your drone, programming your drone, also to plan any mission or giving this mapping, whatever you want to do, what all drone operations we need to do, we'll be able to do it from the ground control station software. So that is your screen here in the laptop. And then you have your transmitters. So this is the radio control device which is used for controlling your drone, for flying your drone. Whatever input you want to give from ground, it is given by the transmitter. So transmitter also has a video display with a video receiver antenna. Your camera will have a transmitter attached to it for long range wireless communication. So here on the video screen, we'll be able to get the live view of the camera through this video RX antenna. And we are using lithium polymer batteries and solid state lithium ion batteries as of now. So they will be the source of power for your drone. Apart from that, you'll be having a receiver. So you have a RC transmitter, which is used in ground for controlling the drone. You have a receiver which will be attached to your drone. So these are the common parts which is there in most of the multi-rotors. And like if at all we speak about the control of our drone, it is not only transmitter all the time. So if the drone is a high altitude, long endurance UAV or a drone, and if its payload capacity is very high, we will actually have a control station at ground. So this control station is called ground control station. So you will be controlling all the activities of that drone or UAV from this ground control station. And this is explaining a specific ground control station of a UAV called Global Hawk. So Global Hawk is a high altitude, long endurance UAV. It has like two control stations. So and also a vehicle test controller. So if you see vehicle test controller is a team working on ensuring the airworthiness of your UAV. So before takeoff, after landing, the vehicle test controller will be certifying the UAV whether it is airworthy to fly or not. So that's the work of vehicle test controller. And now your control station one is responsible for the takeoff and landing of your UAV. And launch and recovery is referring to the takeoff and landing of the UAV. And we have mission control element, which is nothing but the UAV's mission, whatever work it is assigned for. The team at control station 2 will be controlling the UAV to complete that work, get the data, whatever is required, and to return back till the recovery zone of your UAV, after which this launch and recovery element will land the UAV. So this is the working of your ground control stations. So traditionally, earlier we were having ground control stations. You can imagine this is a cockpit-like setup in ground. So all your systems, whatever communication devices, navigation devices, that will be present real time inside this, ground control station. So now, if it is a smaller drone or a smaller UAV, we are using transmitters for controlling them. So now we are just moving on inside the navigation and communication protocols which is followed for the drones. So the first thing we are talking about is the GPS, Global Positioning System. So basically GPS is a device which is used for getting the drone's location, and it is very much useful for planning all the autonomous activities of your drone. So we all use GPS in our life regularly. So I don't have to say much about GPS. We all know what is it, how does it work and all. But in case of drone, we have if you have a GPS, only then these drones will be capable of performing any autonomous mission, whether it is related to GPS or not. But all the autonomous missions have GPS as one of its primary element. And GPS, of course, we know it is a constellation satellite, and different countries have their own GPS. And we use Global Navigation Satellite System, GNSS. Right. So that is giving you the drone's live location. The GPS is responsible for getting your home point or launch point where you take off. We'll record it with the help of GPS. And if at all you want to go for an autonomous mission, so if you want to plan it, the mission planning is done with the help of GPS location only. And all your waypoints, any autonomous or intelligent mode that you want to do will be dependent on GPS. So that is the role of GPS in terms of your navigation or guidance. So now, even though we use GPS for our positioning and tracking, there might be certain errors in our GPS. So RTK is a system which is abbreviated as real-time kinematics, and basically it is making our GPS data more accurate and precise. So if you compare, like there can be, a meter difference, meter accuracy difference in GPS data, but there will be only centimeter level accuracy difference in RTK data. So this is the difference between your RTK system and a drone which is just having a GPS. So RTK will be used in combination with GPS for obtaining better accuracy in terms of mapping all GPS based operations. So that's your RTK. So you'll be having a base station. So we'll be having the GPS mounted on the drone, and you will also have the GPS satellite in picture. So it's a triangle communication between the base station, the drone, and the GPS. So if at all whatever GPS data you have captured have some correction, that will be imposed by the RTK system which we are using. So that's the use of RTK. And you have inertial navigation system, which is very predominant even in our aircrafts. So inertial navigation system is nothing but you are navigating with the help of the inputs from sensors like gyroscope, accelerometer, magnetometer, barometer, etc. So we know gyroscope is like I have their briefing later in my upcoming slides. But just for the understanding, whatever input we are getting from gyroscope, accelerometer, and the other sensors, which is working based on the inertial principle, we will be able to control the drone's stability as well as to some extent the orientation and position of the drone can be corrected with the help of this inertial navigation system. That is the work of INS. So now MAVLink is a protocol. So MAV or MAVLink is micro aerial vehicle link. So it is a protocol followed by my like ground control station and drone to communicate with each other. So MAVLink is the precisely protocol followed by telemetries, which is used for drones. So it supports like all your waypoints, which is nothing but the autonomous flight planning missions, the telemetry data, and any control command which we would like to pass from ground control station to your drone. And it is of PX4 or autopilot flight controllers. All the flight controllers support this MAVLink protocol. So it's like wirelessly transmitting the data between ground control station and your drone. That's MAVLink. And apart from MAVLink, we use a radio receiver for controlling the drone. From ground you use the radio transmitter, and aerially we use the radio receiver. So there are certain radio receiver protocols which is followed between the for the communication between the radio controlled receivers and our flight controllers. So the communication protocols we'll see one by one. So usually the operating frequencies are 2.4 gigahertz, 915 megahertz, 433 megahertz. So depending on the range of operation, the distance to which you want to fly the drone, you can select the range or this frequency band for the radio control devices that we are using. So the thing that we expect from our radio control protocol is it should be having a very low latency, which means delay, and there should be very high reliability. There should not be any mistakes, errors, or failures because of this radio control devices. Some of the brands which is popular for the radio control devices like transmitter receiver are FR Sky, Fly Sky, Futaba, Spectrum, Radio Link is displayed in the picture. Many other brands are there. So this helps in the flight operations and particularly the communication between our receiver and flight controller. Yeah. So the first protocol is LoRa, which is long range. So basically, you will be having a kind of topology for any network whenever you are connecting. So the LoRa network will follow a star topology. So that is the thing. It is a again protocol used for connecting your drone to any of the ground control station that you are using, right? And the next protocol is ZigBee. So ZigBee is like it uses both star and mesh topology, both the topology. So star devices are nothing but they will be communicating with a hub. So basically, if it is star topology, all the devices will be communicating to a hub for getting the data. But if it is mesh topology, the device can communicate between each other. So this protocol will use both these topologies for the communication purpose. And the next protocol or module that we used with your drones is ELRS, Express Long Range System. So they use cross-site serial protocol. It has high bandwidth and very low latency. So it is bidirectional serial communication protocol. So this ELRS can control both your radio control transmitter receivers signals as well as the telemetry data. So the purpose of ELRS is for actually extending the range of operation and also reducing the delays, any errors which is happening between the transmission. So that's the idea. And serial S-bus is also a protocol, which is there for the receiver and flight controller communication. So before going for serial bus, we also have protocols like PPM, PWM, and all. So the analog protocol is PPM and PWM. PPM stands for like pulse position modulation, and PWM is pulse width modulation. So they are all analog protocols. The serial S-bus and serial I-bus is digital protocol. So serial S-bus protocol is very simple. It will allow the receiver to send bidirectional data, that is send and receive data using a single connection. So you don't use many wires for communicating with each channel. So that is the idea of serial S-bus. And serial I-bus is interface protocol. That is also a two-way communication protocol. It uses this universal asynchronous receiver transmitter UART. So that is also a single connection that will be able to transmit and receive data. And this I-bus is particularly used by the brands like FlySky. So this is your I-bus protocol. So far we just discussed what all protocols are there for the communication between your receiver and the flight controller system. So now we are moving into the actual communication systems that is available. So command and control communication system. So now, as we already saw, the ground control station that I explained earlier is a traditional ground control station, which is basically a fixed ground control station on land. So the picture that you're seeing here is a portable ground control station. So this also has all the capacity like the traditional ground control station, but it will be very small in size. From ground control station, we'll be able to control the drone. We'll be able to gather the data of the drone. We'll be able to gather the data of the payload, whatever you're carrying. You will be able to do all the kind of operations in of a drone from ground with the help of ground control station. So this also shows you any FPV like the camera imaging system, payload like spraying systems or other sensing system. All the data can be detected from the ground control station. So this is a portable ground control station. This is a traditional ground control station. So you can see the difference. So a traditional ground control station, a portable ground control station, and handheld ground control stations are also there. So this will be very small. Handheld GCS will be smaller than portable ground control stations actually. So we will be able to see the data, operate the drone, everything from a very smaller sized, accessory. That is the idea. But again, all the ground control stations, the capacity efficiency will remain the same. Only the size will be different. Considering the fact that if GCS is fixed, you cannot operate your drone apart from certain radius of the GCS. So if it is a portable GCS, we'll be able to carry the GCS and we'll be able to operate the drone anywhere. That is the idea with this portable ground control station. So whenever a transmitter is being used, the transmitter uses frequencies like 2.4 gigahertz, 5.8 gigahertz. And I said that the telemetry frequency is already 900 or 915 megahertz, 433 megahertz and all. So, like usually a 2.4 gigahertz frequency can give range of about in a basic transmitter 1 kilometer. So, if we are changing the frequencies and certain components in the transmitting and receiving system, we will be able to change the range, the distance of operation of our transmitter receiver. So, in the picture, we have shown two things also. So, one drone can be controlled by one transmitter at a time. So, that is single control. And a same drone can be controlled by two transmitters at same time, which is called master and slave configuration. That's dual control for your drone, right? So there are devices like signal boosters. If at all you would like to extend the range of your transmitter and receiver signal transmission, then you can use these signal boosters. So they will be devices or accessories that can be attached to your transmitter, something like antennas with different geometry, so that they can extend whatever signals they are transmitting. So this is a radio signal repeater. So if there is a case that you are operating your drone to a very large distance, like let's say 30 kilometer, 40 kilometer, maybe, if you feel that there are interference between this range, it is actually promised by most of the companies that you get a range of about 30 kilometer using a normal transmitter. But the problem is this transmission of 30 kilometer or 40 kilometer is possible only when the land geometry is leveled, which does not have any obstacles on the way, like trees, buildings. If you don't have anything, if your land is completely clear, then you might achieve the 100% range promised by any of the manufacturers. But as per your land topology, the interference also disturbs the signals transmission. Therefore, you can keep a repeater. So intermediate point between drone and the ground control station or transmitter, whatever controlling element we have, we can place a signal repeater that can capture this main sorry that can capture the main signal, and it can reflect the same to the drone, so that you can be sure of that the promised range is obtained by the drone and the transmitter. So this is our radio telemetry system. So I just gave a brief note already. So this is your modules. A radio telemetry module will have like two modules, which is aerial module, ground module. The aerial module will be connected to your flight controllers. Ground module will be connected to your mobile phones, and the ground module will give you the data displayed that is there on the GCS software. So the aerial module will transmit the data from the flight control board to this ground module. So this is its work, and you can see both of them. So the ground module will have a provision to be connected like a USB, and they generally use 433 megahertz or 915 megahertz. So if you want longer range, you can go for 915 megahertz, and if you want lower dispersion rate from obstacle, we can select 433 megahertz of frequency. So this is again, so far we were talking about the drones control, drones transmitter receiver. Now we are talking about the FPV system, which is your imaging system, first person view. So FPV has also got a transmitter and receiver and telemetry system. So the FPV's telemetry system can use many types of data links like Bluetooth, Wi-Fi, other internet-based protocols also, or it can use radio frequencies as well. So the use of any FPV system or this FPV telemetry system is that you can gather the images and videos from your camera to the software whichever is broadcasting the video or photo, but it will be for a longer distance. So when we talk about DJ drones or industrial drones, so they'll be working for 4 kilometers, 5 kilometers range. More than that also. Some drones travel to 30 kilometers. So in this case, if you want a image transmission or video transmission wirelessly, then we use this FPV telemetry system. So we'll be able to see them wirelessly here on our video output devices. So the sensors that we use for the navigation purpose, so that will be my accelerometer. So accelerometer is a sensor or a device that senses the acceleration of the body. So basically, what we do as programming for your drone is you calibrate all the sensors to finally obtain stability. So accelerometer is present in the flight controller of our drone, and we will calibrate this accelerometer for getting proper acceleration measurement during the operation of drone. So that's the work of accelerometer. So the calibration will involve like you have to move the drone at different axes, different position to understand the the drone's movement and acceleration. So that's your accelerometer and accelerometer calibration. Now comes gyroscope. So gyroscope is a device that is even present, in our mobile phone. So many of you might have seen when you're using your mobile phone for GPS particularly, it will ask to make a infinity with your phone. Whenever you're using games like Temple Run, PUBG, all the games utilize this gyroscope facility. So you will be like moving your mobile phones. The character that is seen on your phone will be actually moving without just giving any input from your hand. So simply if you tilt your phone, that character will be moving. If you do infinity, the phone will sense it. So all of this is because of gyroscope. So whenever you place a gyroscope on any body, it will sense the position of that object. Position in your axis is like X, Y, and Z. So what is the position? And if at all there is any issues in terms of stability, the gyroscope will correct it by providing its input to the flight controller. So that is the work of gyroscope sensor. And again, that will also be present in a flight controller. So this is our magnetometer. It is very important to know our direction or heading of the drone. So magnetometer will be helpful in understanding the magnetic field with the help of which we'll be able to. I'm sorry, somebody's mic is who's it? Priya, Priya, please mute your mic.
Yeah,
Thank you.
yeah, I'm
Yeah. So magnetometer is a device which is used for understanding the heading of your drone. So that is a sensor present in your flight controller. By understanding the magnetic field, it will be showing you the north, south, west, east, the directions with the help of a magnetic field strength. And then we have barometer. So we have to sense our altitude. So altitude is sensed with the help of barometer. By understanding the difference in pressure whenever your drone is traveling, we'll be able to know which altitude we are flying in your drone. So that's the barometer. So, like many of you belong to like mechanical, many other backgrounds. So you might have seen the mechanical devices. But if you look at the sensors, so these sensors will be embedded in our flight controller, which most of the time is not visible, but it will be present inside your flight controller. So that will be calibrated whenever you are using it for the drone operations. So far we just discussed the communication navigation systems and their sensors. So now we are just going inside some of the advanced guided techniques and modes available for drones. So the first thing, so apart from the traditional methods we discussed, you can nowadays use certain advanced features for navigation of your drone. So this is a visual navigation which is given. So visual navigation is done usually with the help of cameras and also some of the optical flow sensors that is used for understanding the light. So this visual navigation is purely, you can see the first picture through camera, you see the view and you control it. So that's your visual navigation. Visual vision based control is if at all you have something like sensing a wall, a land, or you have some pattern to be drawn, but it is purely based on the vision of the cameras and that can be done by vision based control. So you have vision based tracking. If you need to follow somebody, if you want to follow a target, then this camera will capture the target and your drone will follow. So that's called vision based tracking. And this is vision based, avoiding the collision, right? So if at all you find any object with the help of your camera, you don't, collide it. You avoid the, collision with objects. So that is this, like vision based SAA. So the next way that we are using, we already saw vision-based navigation. So this is also a type of vision-based navigation. So it's FPV goggles and FPV system we already discussed. So the cameras that is present in your drone can wirelessly communicate with the FPV goggles or FPV receivers, whatever we are having in ground. If you don't use a goggle, you can also use a mobile phone, right? So you need a device ultimately. So it is a video output device. So you will be able to see the data in the video output device, and you will be able to, navigate the drone. So that's like FPV goggles, and the FPV system is mostly used for like racing, high speed, drones, particularly because that gives a very refreshing recreation activity. So this is your FPV goggles. So, and also here I would like to, explain about BV loss. So usually you pilot a drone in B loss condition, which is visual line of sight. You look at the drone, you pilot it. You don't see the camera's vision at all. So how far ever you can see the drone with your naked eye without any accessory, you pilot it. So that's your VLOS, visual line of sight. And whenever FPV comes into picture, it is beyond visual line of sight. So you are not looking at the drone, you are looking at the camera's vision through this goggle, and you're piloting it for a very long distance. So that's your BV loss operation, beyond visual line of sight. So there are drone landing systems. So precise landing system, to be very precise. So accuracy is around 10, less than or equal to 10 centimeter. So you will have a designated landing spot. Either it can be top of a building, top of a car, even it can be top of a truck, like a moving object or a stationary object. But the drone will be able to sense that location where it has to land, and it will be landing on the exact spot. So that's your precision landing, autonomous landing without pilot's help, right? With the help of camera and some of the ground sensors, right? So that's your drone landing system. And lidar systems, of course. So if at all you're going for mapping, so we'll be giving a autonomous path planning, and the lidar based systems will be helpful for both mapping a location, getting the data of the geographical area, as well as lidar systems are available for understanding the obstacles present around us. So for people who don't know, like lidar is light based, ranging, light based detection and ranging. So basically we use ultrasonic sensors, so they use sound waves for understanding the obstacles. Here in lidar we'll be using pulsed laser light. So the dispersion of laser light will be utilizing for understanding presence of obstacle, and even for mapping if you want to map a geographical area. So LiDARs are like 360 degrees. Of course, you can select it as per the precision and accuracy you want. And this is our unmanned traffic monitoring or unmanned traffic management system. So if at all, like now the number of drones and their commercial applications are very less in India. So soon we are expecting the commercialization of drones and drone based services in a very high rate in India. So imagine if you are getting your parcels delivered by drone, you are traveling somewhere, using a air taxi or a drone taxi. So logistics or this transportation, both the industry requires a traffic management system. So you like now it's like a pilot is piloting one drone, and he knows the location of the drone. But if in the same location, if there is another pilot who's flying his drone, he'll not be knowing that there is another drone flying in the location. Even government actually does not have proper knowledge of how many drones are there inside the country, whether they are flying at this moment or not. So this unmanned traffic management system will bring a very good platform for the commercialization of drones. So basically, the unmanned traffic management system will help to connect these drones to a centralized system like ATC, whatever we are already having for the aircraft's traffic management. And basically, it will provide a navigation aid, a proper traffic management and monitoring system. So this is like a platform, or it is like a software that needs to be developed by India. So it is being developed actually by some of the network companies partnering with DGCA and civil aviation based bodies. And swarming of drones. So when you say swarming of drones, it's like the mesh topology, which we already talked about. So the swarm drones are like they are communicating with each other. They will be pre-programmed for doing any like activities together. So when we are talking about swarm drones, it is not like 10 drones or 50 drones. India has achieved around 5,500 drones that can fly together for a light show. Right. So 5,500 drones, if they want to even make this barcode, any, the shape that they want to make in the sky, so the drones will communicate with each other and they will be like going to the position which is already allotted to them, and these drones will form it. And if at all they face any problem, they will be like landing by rearranging its position to the original point, and they will land. So swarm technology as of now is used for recreation, but soon it is expected to be used for military and other warfare operations. And there is a advanced mode or intelligent mode in photography drones, which is called point of interest. So here we'll be utilizing the cameras. We just look at the point of interest, or like whatever target we want to take image or video of, and we can fix the drone at certain altitude and at a certain distance from this point, and the drone will automatically circulate around or revolve around this object, so without control of pilot. So during this time, any photos, videos to be taken can be done by the pilot or whoever needs that video or photo. So this is your point of interest. So we'll be able to give the distance, altitude, and the number of times it has to, circulate around the object. Also, this number of time and the time to be completed decides the speed of drone. So if let's say I'm telling that it should complete 10 rounds in 5 seconds, then the speed will be very high. If the same thing, if I'm saying that I need to do it the 10 rounds in 50 seconds, then the drone will be moving at a slow pace. So this is how point of interest works. And the next mode which we have is active track. So this is like you are tracking an object through camera and it is just following it. So basically, through camera only. So you can track a human, you can track any object with the help of this active track. So there is another way of tracking. Instead of the camera image which is recorded, you can also use some devices, either like a transmitter or some other devices. If AI based, things are done, then the drone will just follow that object. Whoever is carrying that object, the drone will follow that person. So that is another, tracking. So this is the transmitter follow me. So this person will be carrying the transmitter. So the drone will be following that person. So here you are just taking the image of the person. The drone is following that image. Right. So that is the difference. Transmitter follow me and active track follow me. So hand gesture mode, instead of using transmitters or ground control stations, you will be controlling the drone with the help of your hand. So basically, hand inputs can be given in two ways. One with the help of any accessory like gloves, or it can be band, so which has sensors like gyroscope, accelerometer, other position and orientation sensors. So whoever wears that gloves or the band, if they move their hand, it will be taken as input and drone will move accordingly. So that is one way of gesture. Second way is without using any accessories, the drone will use a thermal camera and it will be recording the controller or the pilot's contour, and the drone will be moving as per the input given by your pilot. So this is purely without any accessories, just with your hand. So you say, forward with your hand, drone moves forward. You bring your hand backward, your drone come back. You say bye, your drone comes and lands in your hand. So you can do such kind of controls in hand gesture mode. And we have home lock. So home lock is nothing but whenever you're flying your drone and you feel that your GPS strength is very less, and home point is the point where you take off. So basically, the takeoff point is recorded as home point. So if you don't know where your drone is, you can't visually locate your drone. then you just use your transmitter, enable this home lock, bring your stick of elevator behind the pitch stick to be kept at the lowermost position. So wherever your drone is, however your drone is, the drone will come back to the home point. You have to hold it until you visually see the drone. You have to hold it. So this is called home lock. Your drone is locked to home, and the drone will not cross the home point. So that's because if the drone is at a very high altitude, it will not be visible. But from your GPS location, you will be able to see whether it is approaching home point or not. So if at all, if it is not visually available, you can't bring it properly down. No, once it reaches the home point. So therefore, there is no traveling behind the home point. So that's your home lock and course lock. If at all your drone's direction changes, like the drone's heading changes, I'm visible and audible. Hello.
Yes, 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 ma'am.
Yes, ma'am.
Okay. So my screen is like frozen. Sorry. Right. So the course lock is nothing but your drone will be actually having a heading reference. Only if this drone is placed properly, then your drone can move forward, backward, left, and right properly. If at all you are changing the heading, let's say you keep the drone in a reversed position and you try to fly it, all your controls will be reversed when your drone is in normal mode. But if you enable course lock, even if your drone's heading is not maintained properly, the control directions will be proper. Your drone, if you are giving forward from transmitter, drone will properly go forward. Drone will come back and left and right properly. So the control direction remains the same despite of the heading of your drone. So that's your course lock. So my screen is frozen, sir. Just a moment. Um, so can you still hear me?
Yes, ma'am. Yes, I can hear
Uh,
you.
I think my like the software which is presenting got crashed. Just a second. I'm fixing it.
Yes, ma'am. Yes.
Uh, so I'm just yeah.
Yes,
So
sir.
after uh, after the coast lock, we have return to home. So whenever your drone has any problem, like the battery level of the drone is very low or there is a signal interference, then your drone will automatically come back to the takeoff point and land without interference or input from pilot. So that's called return to home. That can also be considered as a smart feature that is present in drone and a guided system that is present in drone. So apart from automatically getting triggered, we can also call the drone back. So you'll be having designated channels in your transmitter, or you'll be having an option in your ground control station to call the drone back when it has autonomous capability. So the next thing is low battery warning. So we'll be able to see this, battery percentage in our ground control station software, whatever we are using. So always that is again this low battery percentage is set by us. You can keep it as 12%, 15%, so that at least this 12% of energy it can utilize for coming back to the home point. So emergency landing. So apart from return to home, you can also give a command called landing. If you know that you're going to operate either indoor or you're going to operate in a very small visible location, then you can go for emergency landing. So the drone will automatically land without coming to home point. Wherever it is, it will reduce its altitude and it will land. So geofencing, we will be able to create a virtual boundary using the GPS coordinates and the geographic data we have. So geofencing is like you designate that the drone will only travel for either 40-meter or 60-meter, even though the drone has capacity to go for 3 kilometer or 4 kilometers. So if you designate this geofencing, the drone will not move any further than that distance. That's called geofencing. So this is usually done to protect your drone from not getting lost, or if at all you have some highly secured area near you, then it's not favorable to fly your drones there. So you can give a geofence to the same. Collision avoidance. So you use sensors like lidar, ultrasonic, radar based sensors for understanding any any obstacle is present on our way. If at all there is obstacle, the drone will avoid the obstacle without hitting or colliding with the obstacle. The drone will try to restrain the movement moving forward. So that's your collision avoidance. And terrain following. So there are terrain following radars that can be utilized or connected to your drones. So you just understand the land topography. If it is a flat land, you will maintain, let's say, an altitude of 10-meter or 7-meter from ground. The same altitude will be maintained even if the land is not leveled or flat. If it is a bumpy area, mountainous area, so this altitude will be maintained on whatever kind of topography of your geographic land. So that's your terrain following or terrain following radar. Altitude hold, position hold, we can also say that. So the drone will be fixed in certain altitude uh, in this particular mode. So even though if it is having some instability moving horizontally, the altitude of the drone will remain fixed. The drone will not oscillate in the vertical axis. That's altitude hold. And there is something called position hold in DJI drones and some flight controllers, advanced flight controllers. So position hold is nothing but even you just place a drone at one particular location in air, so the drone will hover even if you're not giving any input or even if you're not touching the controller. The drone will still remain in the same position. Even if it is blown away by any kind of gust or other factors, the drone will just come back to the last position where it was hovering. So that's called position hold. So some of the anti-drone systems we have. So drone jammers are available. If at all there is a highly secured area like military camps, other government like places, there will be jammers which can jam the radio frequency. The main source of control for a drone is radio frequency. So if we jam it, we won't be able to control the drone, so the drone will get out of the pilot's control and will just come inside the area and fall down. There is also technology for jamming your GPS. So if it is autonomous drone, obviously it will have GPS, so we will be jamming the GPS and bringing the drone to just fall down. That's your drone jamming. Drone catches. So this is a technology or let's say a technique used before the drone jamming. So you can shoot out a net on the other drone which is entering your area illegally. So that's your drone catcher. Anti-drone fencing. So the jammers can create a fence around whatever the circumference of the area that it is guarding. So that can be called as anti-drone fencing. In that area, no drone can fly. It's like a no-fly zone or a no-drone zone. So jamming and spoofing, even in a UAV or a drone, we can carry this jamming devices so that wherever our drone is moving, we'll be able to jam the other frequencies or other bodies which is trying to influence the drone. That is the this kind of spoofing. And there is radar for drones dedicatedly. So we know about the radars that we see in movies, we see in ATCs. So they are for actual aircrafts. So there are radars that can dedicatedly, understand the movement of drones in a particular locality. So this radars will be useful for the UTMS, unmanned traffic management system, and anti-drone vehicle. So if you are fixing the jammers, all the anti-drone system in a vehicle, and if we move it around, we call it as anti-drone vehicle. It will be very helpful for border surveillance and military operations. There are other drone warfare-based systems, which is nothing but you can launch a missile with tracking, capability to destruct any target that you have, and many other bombs can be dropped using a drone. So if at all you want to conduct the aerial warfare with drones, even recently there were few things that a country used a voice simulator of babies crying, in this one country for just bringing out the people and bomb and kill them. So we call it decoying. So decoying is like you are pretending, you are just using a tactic to bring the attacker forward. So these type of technologies can also be done with the help of drones. And like counter UAV system is if there is any UAV coming inside our premises which is guarded and protected, and you want to stop them, that is counter UAV system. Again, we are talking about the jammers. In case jamming is not possible, they will try to shoot down this drone or destruct it physically also. So I'm open for the questions. If at all you have any questions, please ask.
Participants, if you have any questions, you can unmute and ask the question to our resource person, or you can put it in the chat box so that I'll be ready to ask your questions.
Good evening, ma'am.
Good evening, sir.
Presentation and information is very, you have given in a very simple manner and it is very smooth. I have two questions.
Hmm.
First thing is, like, can I program any controller which is there on the board?
Hmm.
Is it possible to program? Can I put my own program on that?
Sir, whatever is available in market, like we actually have around more than 30 flight controllers, which is available in market. They are more like, printed circuit boards. So we will be able to only upload firmware. We'll be able to calibrate the sensors, and but programming flight controller, that we have to design and manufacture by ourselves. As of now, coding is not possible. That not at least directly on the flight controller, but you will be able to use some additional boards like Raspberry Pi, other AI based technology to obtain any output that you are looking for. As of now, the boards can be used only for the controlling of drone and navigation of drone. Yeah.
Ma'am, if that is the case, the control should be forward or should be communicated from the additional board, whatever happens.
Yes, sir.
Next point is towards coming to the communication part.
Hmm.
This telemetry, you mentioned it is happening at some 900 megahertz or so.
Yeah.
So instead of it, can I have some, like let's say 2G or 3G or 4G kind of base stations that I will be able to Okay, but because now people are talking about something like 5G or so, how that
Hmm.
can be integrating onto this?
So all this networks like 5G, 6G that they are trying to use are basically for the traffic management as of now. If you ask me, in market, we don't have any telemetries that is operating more than like 433 or 915 megahertz. So that 5G technology which they are using is for mass communication for the traffic management things and also.
Lastly, ma'am, coming to the landing,
Hmm.
please say, I mean, fixed surface, it's okay. Let us say some drone is flying above some kind of train or bus kind of thing. Will it
Hmm.
be able to land on the same bus or train? What will
Yes,
be that?
sir. Yes, I visited Japan by 2023. I saw a system live on an expo. So that is this precision landing system, which will just look like a small printer size, where you will be having a map kind of or a surface where there will be certain sensors mounted. So the drone will just come and scan this or identify this sensor, and it will come and land above the device. So this device was like done by a company in Japan, and it has the accuracy to be kept on a moving vehicle also. Yeah, it is
What are the
possible.
technical speeds that you have noticed in
So they, as of what we discussed, it was a car. It was a small car, and on a car it was possible. That's what they told me. Yeah, thank you.
There are a few questions in the chat box. That is, Madan
Yes, sir.
Kumar is asking about AHRS system. It is
Uh,
sensor fusion system. AHRS.
so it is like AHRS is basically referring to the attitude and heading reference system. So again, like inertial navigation system, it will use sensors and their input instead of GPS for getting the position of a drone. So when we are flying, the gyroscopic data is showing the axis of drone, right? So that will be taken care by AHRS, and AHRS helps in improving the accuracy of your this stability. Yeah. So if your heading and attitude is not proper, then your guidance or the navigation will not also be proper. So heading is very important. At least like even when you try to deviate your drone's position and like other things. Yeah. And I guess I
There
got
is
another
another question.
question. How
Yes.
to operate drone indoor without GPS? So far we have a possibility to operate it manually without GPS. Without RTK or GPS, indoor purely by radio control we are operating. And apart from that, some of the vision-based assistance, as I discussed, we can use. And there are certain modes like your course lock that can be used, indoor when you're operating your drone. So it's so that your drone is not getting damaged, and it also you can use collision avoidance system indoor. So all this can be helpful for operating your drone indoor. Yeah. And noise of drone when it is flying. In particular, if drone is flying in restricted area, the noise will create problems. So now this problem will be solved. So that is in the like if you ask me, certain level of noise reduction we can do from controlling the vibrations present in the drone, especially whenever you add a propeller to your motors. Those propellers, if it is not properly mounted, then that will cause certain vibrations. If the propeller is not of proper size, that will cause vibration. If your structures are not mounted properly, that will cause vibration. Even some of the let's say your motors, if they are not properly mounted, that will cause vibrations. So ultimately the noise will be very high when vibrations are very high, I'm not telling that we'll be able to control the noise to a very higher extent, but if you reduce all these vibrations by providing proper dampers, then um, we will be able to control the noise. Otherwise, that's still a problem which is being researched. As well. The noise of drones because of the rotors operation and because of the aerodynamics behind it. Yeah. Manufacturing drone ourselves, there is need for any license to get. Yes, sir, you need to have a company registered under MCA and you need to get a type certification if you are manufacturing drones for any commercial purpose. Yeah,
Ma'am, there is one question from my side.
yes, sir.
How this 3D printing is impacting drone manufacturing and customization? Because
So, India is like moving towards indigenization. Even the hub which we are working together with, the TIH of IIT Delhi, so they are also supporting many startups. So we don't have electronics like motors, ESCs, many of the electronic components manufactured in-house in India. Only like for past 2 years, there are very few companies. They are trying to do it. It's not fully commercialized. But the only hope for the manufacturing sector is 3D printing and other traditional manufacturing methods we are having because the indigenous parts as of now which is being developed in India is your frames, propellers, some of the grippers that we are using for drones and all. Most of them are 3D printed. So 3D printer plays very important role in development of all this parts, physical parts of our drone. Yes, sir.
okay, fine. One final question from my side, ma'am. You have been in this field for more than 7 to 8 years, and you are training a lot of students in this technology.
Yes.
What are the things you expect from educational institution? Because more faculty members are in this meeting. What
Yeah.
are the things you expect? Where we need to concentrate so that we can come up with indigenous drones?
Sir, if actually we work with different types of colleges. So colleges like universities, affiliated colleges, even IITs, some NITs, triple ITs also. One thing I see, the difference is basically in affiliated institutions, you are so much bound by your curriculum, the norms of the affiliated university, and all that. So, therefore, internships and some of the industrial project aspect is not very much concentrated. And moreover, if you see, most of the institutions are running behind your accreditations, right? Even accreditation has certain criteria. I myself have been to many NAC and NBA accreditation, visit as industry person to many universities and all. So the thing committee is expecting from any of the educational institution is to, promote this kind of research activities, skill development activities from a company inside your colleges, and also to promote internships. So these kind of opportunities for the students, but I feel that is not taken very seriously in most of the colleges because we meet students and students the feedback that they give to us during the interview or any skill development program that I'm doing is they are not getting the permissions, they are not having that provision in certain colleges. And I know Hindustan, your college, like you are doing activities on drone on a very long basis, but some colleges they are not doing it. On paper, it might be there, but in real time, those things have to be imposed in college very seriously. And secondly, the students, I have seen a mentality in IIT and triple IT. So actually, I was requested by the, either it is a professor, he is a director, or if he is any other position in that institution, they'll try to connect with the industry and they'll try to get internships for their students. I have not seen that so much in, the affiliated colleges. So I'm just telling that you have to try to connect to more industry If you find the right partner, you have to, be collaborated with them for a long time, and you can expect the benefit out of a good collaboration. That's what, I would like to conclude here.
Yes, thank you, ma'am. Thank you.
Thank you.
Hope
Thank you.
participants
And
would
I
have
think I
changed our
just have like finally two,
question.
three.
Yes, ma'am.
This certificate, type certificate, sir, Shivakumar said the type certificate will be provided by DGCA. So DGCA will be providing type certification. You have to test your drone under some quality assuring agencies. So authorized testing entities they call. So ATs have to test your drone. They have to certify. DGCA will give you type certificate. And longevity of a drone of weight 10 kg or so. Endurance you can expect from 20 minutes to 30 minutes. So you can just compare a 10-liter drone of agriculture. So if you see the specifications, that will be equivalent to the 10 kg payload drone also. Yes, sir. And simulators for designing and testing. Uh, Phoenix simulator has a builder, so you can use that software. Some of the virtual reality platforms like Meta and other platforms, they provide such simulators. So you can test it. So your 10 kg drone endurance is dependent on battery as well as your payload. Let's say if you want more endurance and more altitude, let's not carry more payload. Yeah. So ISO is like quality ensuring body, sir. ISO even has many standards, but DGCA has this bodies called authorized testing entities. Like you have BIS certification for products, and we have this 916, hallmarking for gold. So similarly for drones, you have bodies called authorized testing entities. So they will be testing the drone. Yeah.
Yes, ma'am. I think. Do we need
So
any
do we need
certificate for
any
flying?
certificate FPV less than 1 kg? It depends on your application, sir. If you are using it for education or research, please register your drone as a model RPAS, model remotely piloted aircraft system. If you have that, you don't need any license for flying. If it is commercial, then yes, we have to register the drone, and you have to have a license. Yeah.
Yes, I think
Yes.
that's all with the question.
Yeah.
Thank you, ma'am. Thank you for your time, and hope in the future we'll join together and we'll work on some collaborative projects. Thank
Sure.
you so
Sure.
much for your time.
Thank you.
Thank you, ma'am.
Thank you, all the participants. Thank you, sir.
Thank you, ma'am. Participants, you can kindly hold on and we'll start the next session in another 5 minutes. Kindly don't leave the meeting. You can stay in the meeting. We'll be starting a session in another 5 minutes. Kindly hold on. Participants, we are contacting resource persons for their PPT. Once we receive the PPT, we'll be sharing it in the WhatsApp group. And as I mentioned yesterday, we are recording the entire session and we'll be uploading the recorded video in our YouTube channel. Once it is done, we'll be sharing the YouTube channel link also in this group. So we'll be sharing the PPTs. Yes. Yes, sir. We'll be uploading all the videos, sir, all the sessions one by one. We have already started the work, and from tomorrow onwards, we'll be uploading in our YouTube channel every day. Videos we'll be uploading. So once it is done, I'll be sharing it in the WhatsApp group. Yes, sir. We have a WhatsApp group, sir. Hope you are available, sir. Shivkumar sir, we have a WhatsApp group. I believe you are available in that group. So we'll be sharing all the details in that WhatsApp group.
Hello.
So,
Hello.
yes, sir. So, yes, sir.
Sir, can you hear me?
Yes,
Audio is
yes,
okay?
sir. Yes, sir. Fine, sir. You are
Yeah,
audible, sir.
yeah. Yeah. Good evening. And we'll start in a couple of minutes. Thank you.
Yes, yes, sir. Yes. So, dear participants, we are going to start with the second session for today. I'm indeed very happy to welcome our resource person for this second session, Dr. J. Bruce Raflin Rose. He's an associate professor of mechanical engineering department at Anna University Regional Campus, Tirunelveli. He has obtained his bachelor degree and master's degree in aeronautical engineering from Anna University. He holds a PhD degree in the field of aerodynamics from Anna University. From Anna University. He has published more than 75 leading SCI indexed journal articles in aerospace engineering and archival journals published by Elsewhere, Springer, World Scientific Singapore, Inter Science, and Emerald UK. He is an editor of the book titled Cloud IoT Systems for Smart Agriculture Engineering, published by Taylor and Francis during August 2021. He has also published several book chapters in the bio-inspired aerodynamic perspective for various aircraft and drone application. He has completed two major funded projects sponsored by Department of Biotechnology and Tamil Nadu State Council for Science and Technology. He is a technical consultant for Butos Aerobatics Corporation, New Delhi, and Blue Green Private Limited. He is a DGCI certified drone pilot for all kinds of remotely controlled vehicles and an approved chartered engineer for drone enabled inspection and certification process. He has chaired many international and national conferences organized by various institutions across the country. He is an Anna University recognized research supervisor and produced successful PhD scholars. He was awarded as an outstanding reviewer by Elsewhere publication during 2015 and 2017. He has also delivered more than 100 expert talks in faculty development programs, workshop across the country to raise the nation's aerospace potential to the next level. He's collaborated with many IITs, Curtin University, Australia, and National Taiwan University to establish modern laboratories at Anna University in the field of aerodynamics. With this few words, I would like to welcome our resource person, Dr. J. Bruce Raflin Rose, sir. So, welcome you, sir. The session is yours, sir.
Thank you, Professor. Thank you. Thank you for your warm welcome. Now, can you see the screen now?
Yes, sir.
Okay.
Sir, but it is not full screen, sir. Can you go for full screen mode, sir?
Yes, sir. Let me enable it.
Yes, sir.
Is it okay now?
But white screen is only visible, sir. Contents are not visible.
Uh, mm, Let me try this way. Uh, is it okay?
Yes, sir.
Okay. Thank you.
Yes, sir. Fine. Thank
So, I hope this is the day one, right?
you. Second day, sir. Second day. Yesterday we had
Second.
two sessions.
Okay.
Yes,
Okay.
sir.
Fine. So, in this wonderful evening, actually, a most interesting topic is proposed here, that is AI-driven drone system. And I hope already in the previous sessions, some basic insights already offered to the participants. And now my presentation is going to be myself, Dr. Bruce, and Professor Saravanan gave a wonderful introduction also. So I have been working with bio-inspired drones for the past 7 to 8 years, and especially now we are focusing on the drones with specific defense and commercial applications. So in this presentation, I can summarily say that how AI plays a vital role in drone technology, how the data acquired through the drones can be utilized effectively in order to fulfill the applications of drones. So in that way, I can broadly classify my presentation into two parts. And the other side, how the bio-inspired drones can be developed and what is their significant role in the future aerospace engineering, not only with these unmanned aerial vehicles, even autonomous underwater vehicles also, unmanned underwater vehicles also, how we can use this drone technology and AI to build a strong military and other applications. So in this perspective, first let me start with the first point, how the data science and AI plays a pivotal role in AI and other applications. Then subsequently we'll move on to the bio-inspired things. So the contents of the presentation, basically the introduction, objectives, and how the drone market is segmentation is placed now, types of drones, and I'm not going to say any applications here because a dedicated session is given for the wonderful applications of the drones. So I'm not going to give the application based things right now. So my presentation is more focused with AI and data science perspective. So then, yes, as we know, one of the most important goals of AI is to make efficient use of large data sets. And we know if you are using a photographic drone or agriculture drone, any specific type of drone, what it exactly doing is a collection of data. Now, after the collection of data, how it is going to be processed, whether the collected data is in a useful form or it is in the raw data form, we don't know. So, before selecting a specific drone for a particular application, before selecting a specific camera or electronic devices for a particular application, we have to prepare a roadmap first. That is how we are going to collect the data, whether it is in an automated way or with a human intervention, or it is with a semi-automatic manner. In that way, there is okay. Let me complete this introduction first. With the increasing speed of spread of drone technology, the availability of high-resolution images used for various tasks such as maintenance, surveying, mapping, and monitoring is increasing. So basically, if you are considering a image data collected through the drone, we may collect 1K image or 2K, 4K or 8K image. If you, let's say, 4K resolution is required for your application, and we know that if you are taking a photograph with 4K resolution, it will be maybe 10 MB or 12, even more than that. The size of the file will be more than 10 MB or 12 MB, like that. So what happens is, if you want to process a large volume of images, for example, if you are doing some, if you are going to use the images for some deep learning or machine learning based analysis in through AI, you need at least 5,000 or 10,000 images for a particular application. I will tell you the real-time cases also in the mid of my presentation, how we suffered, how we experienced various difficulties when we collected the 4K images for a specific analysis. So if you do that, what happens is 5,000 images, in the sense their data will be in several GB. So how these data can be transferred to the GCS, ground control station, or how it is loaded to the cloud, what kind of transmitter receiver you are going to use in the onboard drone. So that is a big challenge. Basically, the entry level drones and the research purpose drones may not be able to fulfill those real time applications. So particularly the many software companies on the market offering intelligent data analytics solutions to make the unstructured data into actionable one without time consuming manual analytics. So since the field is the emerging one, every day they are making different, the ANN, CNN, various architectures evolving with the different strategies to now, the concept of quantum computing is evolving. So what they are doing is making the data in the actionable form without the time consumption and without much manual involvement with that. Okay. So UAV observations fill the gap between insight and satellite data. We know that because we can take the closer images. So advances in machine learning, data management, and cloud computing are having a significant impact on this market. So according to the report revealed by United States Federal Aviation Agency, almost 6.47 million small drones are expected to operate in the United States by the end of 2024. These statistical data in numbers not specifically available for our country. The reason is most of the we know nowadays in many festivals and many that is marriages and other functions, people are using simple photography drones. Most of the drones, other than this small and nano category, they are not even registering the drones properly. It is not registered with the digital sky. They are not utilizing it with proper documentation and log data. So what happens? We don't. End of the day, we cannot identify how many number of drones are in operation, and there is a need of streamlining this segment also. Okay, I'm not going into the DGCA regulations and how these to be regularized and all those things. I'm not going to discuss. Maybe you have a separate session for unmanned aerial system rules and regulations part. However, you should know the exact numbers cannot be defined as on status. Okay, so we can say it in approximate manner only. What are AI driven drones? Basically, the definition of drones integrated with the AI are called AI driven drones. So the key functionalities of these AI-driven drones are mainly the autonomous navigation, object detection, collision avoidance, reinforcement learning based things. So all those capabilities are essential for AI driven drones. So the end of this AI driven application is more efficient, precise, and it is scalable. So core components of these AI driven drone systems, basically it starts with the sensors. Maybe it is a lidar or inertial measurement units or camera or whatever the sensor may be. In the case of nowadays, we are using firefighting drones, which are using the smoke detection sensors. So sensor can be a specific thing, transducer, which can be selected based on our application, and processing units, uh, graphics processing unit, tensor processing units, GPU, TPUs, and actuators and control systems. These are the hardwares, something different from your basic conventional drone system. We know these. The typical hardware of your conventional drone is your flight controllers, your motors, your conventional propellers and frames. All those things are defined for the essential hardwares for your drone, but here it is something different. You can see the GPU, TPU. That is the most essential thing to process the large volume of data in a shorter period of time without any human intervention. Then softwares, AI algorithms for perception and decision making, and communication systems for real-time updates. So these communication systems also need to be developed indigenously, because nowadays we are largely depends on other imports. So it is the software part, the first part of this one, AI algorithms for perception and decision making. Almost we are moving in a rapid phase to develop that. However, these real-time updates based communication systems and hardware, we are a little bit lacking, and we have to move forward. So this data science research workflow starts with data collection. First, the prior to data collection, we have to define the problem and research design. Then data analysis, data validation, and report creation. So here it is data collection from secondary sources, primary sources, then data analytics. We have different approaches: top-down approach, bottom-up approach, like that. Then data validation process. So the scope of research is very much essential. It is for identifying the limitations and creating the research design. In data collection, it begins with consolidating our own proprietary data as well as the available secondary data. Here, simply we are saying that data collection is the first part, but there are so many difficulties involved. For example, recently we are engaged with wind turbine blade inspection project. What happened was they have the company, the customer side, they simply told you just use our 8 megawatt facility, that is each 2 megawatt turbine. So 4 turbines will allocate to you. You can utilize it for collecting your data, like that. But the thing is, you need to have a healthy data set first. For example, if you want to analyze a blade, whether it is cracked or there is any surface defect, or it is there is a it is a fiber reinforcement plastics, so there is a fungi or any other surface based cleaning is needed. So before processing the particular image for AI or data analytics application, you need to collect a healthy blade data first. Most of the time what happens is, these people, that is so-called your customers, they won't give you the healthy data set, healthy data blade data set to you, because the reason is maybe it is restricted with company policy or trade secret or whatever. So what happens is, without having this healthy data, healthy blade data, you cannot analyze the faulty blade data. That is the problem. For example, if you are studying the wind turbine blade structural health after some 10 years or 5 years of time, if you want to make a conclusion that it is having some minor cracks, or there is a crack nucleation, or there is a patchwork is needed, the composite repair is needed, something like that, means you need to compare all those different kind of problems with the master database. So data collection itself a challenge. The Kaggle and other databases, they are giving some sample data sets in order to study the nature of AI-based applications. Most of the time, the key part of the data points will be missing. What they do is they'll remove that, and once you are a subscriber for the particular thing, then only they will reveal the crucial data to you. So once it is the foundation. Once data collection is pure and perfect, you can boldly move into the next segment, data analysis. That is the part here. So now once we have collected and consolidated all the necessary data, as I told, it is a point we can begin our analysis, and the primary objective is to produce the reports. Obviously, as I told you, this blade inspection and all, what they conventionally do is that they prepare the reports based on the manual intervention. The people are used to move over the blades through the ropes, and they will collect the data, and for visual inspection they use the binoculars and other remote visual things, and based on that they will collect the real data. So from those data reports, we need the basic informations. We have to interpret those reports, and how exactly AI can be used to enhance those reports, how our AI analysis will be more refined, more precise than the conventional data. That is the primary objective here. So for that, we can use any different approach, top-down or bottom-up approach, or any different statistical analysis we can perform. So drones are adding more value to the data analysis by these actionable trends, and mostly you have already most of the participants familiar with these seaborn and pandas in Python library. So if you have a standard data set, how the data set can be processed and cleaned and can be utilized for better visuals and trends. So hopefully, if you are familiar with that, you can easily understand what I am trying to illustrate here. Mostly those data analysis points from you are preparing pie chart or scatter diagram, all those things, you will prepare it with Excel data. But the real challenge with these drone data, mostly the data set is in the form of image or videos. That is the challenge here. So which data is necessary for the study, first thing. Then what data do we currently have on hand? And then which data can only acquired through our primary research. So for our data collection, other side for confidential data or any restricted data sets, I'm not said anything about it, but those things also needed. For example, if you are analyzing a chameleon, or if you are analyzing a rare species in a forest, it is not possible to collect the data just like that. There are statutory procedures, and even in order to operate your drone over a forest or some remote environment, plenty of approvals needed. So which companies, customers, technologies are being considered for the data collection is also another challenge. And what form of analysis is more suitable for our case, whether it is a quantitative analysis or qualitative analysis. In most of the cases, for example, if you are making if you are using your drone technology for survey purpose, it is obviously it is quantitative in nature, because you have to say this many acres, this many cents. If it is agriculture application, per hour, how much area you can cover in order to spray the pesticides and all those things. So that is a quantitative case. Whereas if you are studying the wind turbine blade, and if it is needed for a cleaning, there is a sand erosion or there is a fungal formations, all those things, if you want to study that, mostly the data set will be qualitative in nature. So you will give a justification that the accumulation is minimum or moderate, or it needs serious attention. If you give the reports in that fashion, it is qualitative in nature. Or if you are giving the data set after the analysis, if you are giving the report in numbers, it is quantitative in nature. And the machine learning techniques used in drones, basically supervised learning for classification task, example object recognition and analysis, and reinforcement learning for autonomous navigation, that is based on the environment. The system learns the environment and accordingly it will take autonomous decisions. For example, if you are operating a drone and it is placed by some erroneous operation, it is placed somewhere in the middle of a tree or in between some complicated branches. So if you enable the collision avoidance system, or if you enable the geofencing mode, or whatever it is, the capability incorporated with your FC and other onboard systems, it will take autonomous decision and it will come back to the RTL mode. So when you give RTL or when you give RTH mode, what will happen? It will take autonomous navigation and it will be landed safely, subject to the condition that the amount of power is available. So these reinforcement algorithms are evolving now in order to make the drones more autonomous and more smart, and it will be more helpful, especially when we talk about this swarm of drones. Then deep learning for real-time video analytics and sensor fusion. And in this deep learning part, for example, if you are capturing a human eye, it will, in an earlier case, the conventional machine learning algorithm will say there is an eye, that's all. Now, later on, it was evolved as whether it is a human eye or it is animal's one or it is something else. Then later it has reached a state of it is a human eye under which age group, whether it is 30 to 40 or 40 to 50, because the surrounding features also taken into consideration. Your eyelids and your other features of your features around your eye will be captured, and based on that it will compare and it will give the data. Now it is further refined, and these deep learning modules will give you, for example, if you are taking a snapshot of a banana leaf, or if you are taking a snapshot of your a plant, instantly it will recognize whether it is healthy or it is unhealthy, or what kind of deficiency, what kind of vitamin deficiency is the crucial reason for the particular defect on the particular surface, what is the age of the plant. So these characterizations are very much helpful to arrive AI driven solutions. Then particularly if you talk about agriculture based applications, based on the health of the plant, instantly we can fix how much amount of fertilizer is needed in order to achieve 100% yield, or how much pesticides are needed in order to have a healthy plant in the particular specific land. So in that way, deep learning for real-time video analytics and sensor fusion will help in many ways for our advanced drone technology. Then transfer learning for adapting pre-trained models to specific scenarios. So these four machine learning techniques are the advanced state of our computer science people. That's what in the first slide itself I have mentioned. It is my presentation will be something multidisciplinary in nature. So if you are a aerospace person, you are well versed with the drones, you are a licensed pilot, and you can customize your flight controller for your application. You can customize your propellers, motors, landing gears, whatever the case may be. We may not aware of these machine learning techniques. So definitely we need a computer science person's expertise and support in order to integrate these technologies with your smart drones. So that is something, though I am using the term smart drone, it is not fully autonomous. So we are trying to make our drones towards the smart ones. Okay. Then the objectives and role of drones. So this is a very basic thing, to define, describe, and forecast the size of the commercial drone market based on segment, region, country, application method, and industry. So as of now in our country, we have arrived the liberal policy towards agriculture-based applications. Mostly other applications are slightly restricted, and slightly they are making it liberal through specific policies right now. But if you consider Switzerland, US, and other countries, they are trying to make more liberal drone-based policies, so that the industry is growing rapidly over there. And to forecast the size of different segments of the market with respect to various regions, we need to identify key drivers, opportunities, and restraints influencing the growth of the market. So we have to identify the technology trends that are prevailing in the drone or counter drone industry. I will explain what is counter drone industry at the end of this presentation. If you are making a military version of your drone, instantly what the opposite country will think about it. They will immediately prepare a counter drone in order to hack or in order to destroy your drone at the earliest. So this counter drone technology is also evolving as a big market space. Okay. Now, to profile leading players in the market based on product and service portfolios, financial positions, and key growth strategies, to analyze the commercial drone regulatory landscape by identifying national drone regulations in different countries, to strategically profile the key players and analyze their market shares. These are the objectives and the roles of drones. This is the drone market segmentation. Here you can see the hardware market. It is multi-rotor, single rotor, fixed wing, hybrid wing, lighter than air, and you can see all these types. You can Google it, and you can see most of the conceptual designs in YouTube and other social media. How these multi-rotors are powered, how the single rotors are powered, how it is launched, how it is performing the landing, camera vision systems, navigation systems. So basically, other than the flight controller, your transmitter, receiver, frames, motors, and all those things, other cosmetic changes are like these added GPS, added features in the system may help you to get different type certifications. For example, if you are using an agriculture drone for a particular purpose, if you are going to use the same drone for your painting requirement, if you are going to paint your house through the same agriculture sprayer, you need to customize your nozzle, you need to customize your motor, and there is a minimal cosmetic changes needed. For that changes, you can get a separate type certification. So this hardware industry opening a brand new door in order to have new possibilities and new patents, new business opportunities here. And in the same fashion, software side also, nowadays these agri drones are using Aero GC software. It is indigenously developed for a specific application, agri applications only. Other people mostly, they use the commercial softwares. However, in the view of these data analytics, data transfer, and high intensive computational data analytics, there is plenty of space in order to have advanced software codes and software analytic tools also. Not only with drone navigation and applications for fleet operation and management, even ATC, the drone ATC also. Now we know it is restricted with red zone, green zone, and yellow zone. We have different zones in order to operate our drones. If you have a effective drone traffic management system, we can reduce the size of these zones so that the people can have more opportunities, more liberalized usage. So there is plenty of scope towards the customized software for not only with onboard integration hardware, but also with other subsequent part of the drone application also. Then in terms of services, it is familiar for you. It is drone as a service provider, business internal services, system integration, engineering and advisory, education, simulation and training. Recently, it was very interesting to know that one in country they are using noise recognition sensor based drones. If you have a large firm and maybe it is cement manufacturing or it is a large scale manufacturing industry, they will record a noise level at a different segment of the industry, and they will use the drone uh, maybe once in 30 minutes or once in an hour in order to roam around the particular industry premises. It will recognize that if there is any abnormal noise level in the system. If there is a decibel change beyond the acceptable range, instantly it will alert the server, and based on that, they can do the preventive maintenance over there. So that much it is helpful to enhance the safety features of an industry. So services side, limitless opportunities are there. So as of now, drone market segmentation can be broadly classified in these three. As maybe the participants, those who are listening now, you are undergraduate student or faculty, or you are doing some PhD research, or you are an industry person who is involved with this hardware development or anything. You can instantly fix your eye on your specific interest here. So you can determine whether I can work with cosmetic changes or I can work with the master hardware optimization or any software changes like that. Okay. So the types of drone also I will move in a quick fashion. Here you have single rotor drones. So single rotor drones are very familiar for you, and it is the cost is around 25K to $300K. And these are multi-rotor drones. It is widely known for you. These are called fixed wing drones, and these are fixed wing with hybrid drones. And though I am giving these illustrations here, most of the models are in development, and they are continually making the changes. As I told you, apart from the main hardware components, most of the cosmetic changes coming every day, and they are trying to incorporate then and there. So the present illustrations may differ even when you go through the internet. So these are small drones suitable for hobbyists and children, and these are micro drones. So these micro drones, especially the FPV drones, first person view drones, are playing a crucial role in the case of tourism industry. If you want to see the valley, or if you want to see the beauty of inaccessible place, you can operate these FPV drones over there, and you can enjoy the views locally. So definitely it is going to make the drone a bigger transformation in the drone industry. But as of now, the privacy and other concerns are there, and maybe with the help of AI and the automated systems in the near future. These FPV drones definitely they transform the current phase of the drone industry. Then these are tactical drones, and these are reconnaissance drones, but is exclusively developed for military applications. Then large combat drones, non-combat large drones are there. So target and decoy drones, GPS drones, photography drones, racing drones are there, special purpose drones. So what it is even beyond that many application, many types of drones are there. Altogether, I am saying it is a special purpose drones. Now, why I am giving the type of these drones in the AI-driven systems based presentation is each and every drone has specific application, and for that specific application, the data collection process, data analysis will be entirely different. That is the thing you should understand. For example, if I am talking about this serial number 5, small drones, what we will do, we will take up some good sceneries, good photographs using these drones. If you are going for a holiday picnic, you will take some images, and if you may utilize it for a minimal survey application. For this application, you have to your data collection will be restricted with some specific volume, and your accuracy needed is maybe the 1K image. For that, this small drone is sufficient. But if you talk about some large scale application, if you want to have a closer view, for example, if you want to have a closer view of a wind turbine blade when it is actually installed, you have to use you can use a FPV drone, or you can use some other drone with more than 1K resolution. So for that, when you do the data collection, you need to have a different transmitter receiver system. You need to have a high data resolution, high data transmission rate. So for that, definitely you need to, sometimes you can, if it is a customized drone, you can modify specific features. If it is a DJI drone, or it is a non-customized case, then you have to change the entire drone for your requirement. That is the case. So again, this is the hardware side. Once you change the hardware side, whether the data you are going to collect can be converted into the useful form or not. If it is not so, then again your investment will be wasted. So that's why I'm giving these types of drone. So before, though we are talking about software side, AI tools and all, the person who is dealing with the data, the person who is going to do the data analysis should be familiar with these types of drones and their capabilities. So once they give some raw data in a unreliable form, the entire process will be wasted. So that is the thing. Then you have okay. For example, if you are selecting an agriculture drone, I'll confined with this type now. Are you wanting to map small fields or hundreds of acres? Will you fly tight, craggy ranching terrain, or wide, flat swaths of lower corn? And do you grow crops in cold, windy, and wet areas, or in a temperature paradise? So if it is, for example, if you are mapping hundreds of acres, then what about your what about your multi-rotor configuration? Is it capable to cover the 50 acres or 100 acres of land in a single day? Is it possible to, though you are doing some battery swapping or whatever the advanced mechanism you may have, is it possible to cover? So for that case, as compared with your multi-rotors, maybe you can go ahead with hybrid or fixed wing counterpart. Then what about the terrain? What about your temperature? So these things play a vital role, because if it is a windy region where some 7 to 8 meter per second wind is there, then instantly what happens if your actual endurance of your drone is 40 minutes means if there is some 7 to 8 meter per seconds of wind, that too some gust, there is non-uniform wind, what happens? The endurance suddenly drops to 25 to 30 minutes. So if you are using some RTL mode after some 30, what happens? The battery will be drained. If the person is not aware of all those fundamental aspects of the drone hardware, they will spoil the drone simply. That is the case. Then in the middle of these operations, sometimes if the data is stored in a cloud system, that too with a third party supplier, it is very difficult to retrieve the data also. Again, there is a key needed and other subsequent difficulties are involved. So answers to all these questions will give you a clue as to which drone to be selected for mapping your farm, or which drone to be selected for applying your fertilizer. So, for example, if you are seeking to fly vast farm fields with pastures, you might require a flight efficiency. So, as I told you, a hybrid or fixed wing drone is more suitable. If you are going to use your drone for a very small application, maybe for a artificial drone pollination process, bee drones, then it is very difficult to navigate, it is very difficult to control. So you need to customize your drone with multi rotors, and you have to uh, you have to operate the drone according to the local wind speed and according to the local conditions which are suitable to have a safe operation. So other things, these are important parameters: form factor, flight time, sensor payload, range, even the wireless range, that is the diameter representing the uh, uh, farthest distance away from which the drone can fly from the operator. Though we are using nowadays VLOS only, visual line of sight, this wireless range is very crucial. This is typically much less than the physical range. Regardless, in the United States, it is illegal to fly your drone beyond your visual line of sight. Even BV laws is not authenticated here also without proper authorization. So payload capacity, the maximum weight that drone can carry, you should, for example, if you are adding a lens in your mapping drone, or if you are adding some auxiliary system with your mapping drone, what happens is the battery will be drained quickly. So according to the hardware integrated with your system, according to the data transmission capabilities, that's what I have mentioned, cosmetic changes incorporated in your system, you have to customize the battery. Sometimes you need to add more cells in your LiPo battery, or sometimes you may need to have more mAh batteries. So according to that, we have to customize your payload capacity versus range. Then cruising speed, how fast the drone flies when at optimal velocity. Automated crop counting software uses your phone to fly the drone, automatically collecting data at key points in your field. It is capable of distributing pollen at a specific rate across the specific broad strip, so we can control the pollination process. Then it creates the field reports on crop health, problems, and progress. So for this automated crop counting software, we have tried with banana farm in southern part of our state. We have utilized a drone in order to collect the data. Actually, we have utilized it for crop counting as well as crop health monitoring. And we have collected around 5,400 images from the particular field, and we have identified several common diseases also, several vitamin deficiency patterns also from the agriculture department, and we have utilized the RoboFlow tool. You can Google it afterwards, RoboFlow. And we have trained all those images with our machine learning model. And finally, we have concluded that in that particular field, the banana trees are with some 3-4 common vitamin deficiencies and 3-4 selected diseases. However, it was 72 to 78% only accurate. The reason was we have utilized the drone with 1K image resolution capability. Another thing, when we are operated the drones very close to the banana trees, there was a there was a shake. Obviously, the wind speed down the propellers disturbing the leaves. So we have operated at some specific distance from that and utilized the zoom in zoom out options to capture the images as far as possible. And this is the work we have done in the year 2022. Now it is 2 years over, and now the systems are more improved, and we have more advanced mechanisms to overcome all these difficulties. But however, this automated crop counting software, we have developed the machine learning model, helped us to identify the diseases, and we have developed a mobile application also. So with that mobile application, if you take the image using your mobile phone in your field, if you are taking a image of your banana leaf, instantly it recognizes whether the leaf is a healthy one, or what kind of vitamin deficiency is there, or what kind of fertilizer is needed to overcome the deficiency. So instantly you will get the basic information which are needed to which are much needed for a farmer or agriculture officer who are involving with that. So it is easy for the department to release the uh, compensation, or it is easy for them to supply the fertilizer needed for a particular place. So we can ensure more yield, we can ensure more profit for the local farmers. So in that way, AI driven tools are much helpful to find the field reports on the crop health for both the policymakers as well as the farmers. So it can simply bridge the gap between, for example, if you are for example, nowadays we know the abnormal weather patterns are there. So if your crops are insured and the farmer is saying that around 10,000 banana trees spoiled, or 500 coconut trees spoiled, in most of the terrains, it is extremely difficult for the agriculture officers to collect the exact data. It is not at all possible for them to go to the field and count the exact damage and give the actual compensation needed for the farmers. With the help of this AI-driven drone technology, what we can do is we can do the crop counting. We can use the crop counting software, and we can prepare an exact report so that both the sides we can arrive a consensus. The farmers also satisfied and the policymakers also satisfied with real-time data. This is the one illustrative example I am giving here in connection with these agriculture based drones. Other types, other applications, mapping and other things, you can imagine the opportunities involved with other applications. For example, if you are making a survey, land survey, in most of the areas what happens is people always resist in order to do the actual survey. So what happens, you can use a drone and you can fix the lat long, and you can measure the actual land according to the land survey department data, and instantly you can identify who is encroaching over there, and you can give the notice and sort out the issue. If you are measuring the built-in area of a particular building, you can use the drone to measure that, and you can fix the actual tax for the particular building. Nowadays all these things are manually done, and uh, obviously there are adjustments with the particular system. What happens if the actual tax collection is 5,000 rupees and tax collection needed is 5,000, means they will fix it with 3,000 or 2,500, and it is making, they are making a huge revenue loss to the department. So these are the illustrative examples I am giving. AI-driven drone technology can be moved to the next level to sort out all these real-time gaps exist in the industry. Now these pollinating drones. So Walmart has filed a patent for robotic bees that would pollinate crops that's like the real insects. You know, the scarcity of bees is a real challenge now because the excessive use of pesticides, it is declining now. So what we can do is we can develop these pollinating drones, robotic bees for autonomous pollination. Though it is against the biodiversity, it is against the nature. Food insecurity is a serious challenge, especially in the case of the abnormal weather patterns prevailing now. In order to ensure the food security, it is the essential step we need to move. And this one is the system which is developed by the university research team, MIT. It is capable to pollinate the plants very similar to the real insects. It would significantly pollinate the crops than crop dusting, and about 1/3 of the food we consume, fruits, vegetables, herbs, and spices, depends on pollination from honeybees. So pollinating drones monitor the crop health, its hydrophobic and hydrophilic nature, and patterns, aging patterns as well. So you know the healthy plants, healthy leaves have the nature of hydrophobicity. You know the lotus leaf. When it is young and healthy, what happens is the water droplet simply rolls off from the surface. But when it is aging, what happens? Becomes hydrophilic in nature. It is more wettable. Same thing you can observe with rice leaf. You can observe with banana leaf everywhere. So these robo bees can easily identify the crop age, its health, and aging patterns also. So based on the crop's age, we can customize the amount of fertilizer needed. We can customize the care needed in order to have maximum profit. Then, while pollinating the drones, some researchers are taking another route. They are equipping live dragonflies with a tiny backpack that creates hybrid drone for use in navigation. A tiny backpack on the live dragonfly sends flashes of light to the insect's central nervous system. These activate particular navigational neurons and give scientists control over the dragonfly's movement. So this is a kind of hybrid system, bio-inspired hybrid drone system. So maybe we can expect it in a couple of years. It will transform this pollinating drone segment also. However, the challenges associated with these micro drones, you can see the mass versus wingspan pattern. The mass of these drones restricted with 10 power minus 2 minus 3 kg. Here you can see that with that limited mass requirement, you have to place your DC motor, piezoelectric actuators, rubber bands, your engine, that is the power system, whatever the battery or whatever you are using. All these things should be customized within the weight. And from this point, here you can see the numbers. Serial number 1, micro robotic fly. 2 is artificial butterfly, and 3 is your see the point and weight. Okay, so how exactly the range of the weight? Delphi micro, 3G ornithopter. These are the different nano hummingbird. I'll show some illustrations here. So this is really challenging to develop these micro robotic flies. Maybe with the help of advanced shape memory alloys and lightweight materials, it is going to be more realistic in the forthcoming years. But however, extensive research and serious attention is needed towards this segment. Maybe if you are very much interested to here, you can kindly remember the masses of serial number 1, 5, 6, and 13. That these are the examples are going to show here. Despite these challenges for small-scale propulsion and miniaturization, researchers have successfully reproduced the bio-inspired flight system in several different ways. Here you can see serial number 1. That is your micro robotic fly here. This is in a research level, and this one serial number 5. This is your Delphi micro, and this serial number 6 and 13. 6 is your 3G ornithopter, and 13 is your nano hummingbird. You can see the nano hummingbird here. So all these illustrations available in your these two references, that is Science, Technology and the Future of Small Autonomous Drones. It is published by Nature Journals. And another one is your Design, Aerodynamics and Autonomy of Delphi, Bioinspiration and Biomimetics Journal. So for entry-level researchers, you can refer these articles in order to have better insights about it. Then okay, then we'll move on to these advantages of these AI and IoT for spraying drones. Particularly when you incorporate AI and IoT systems for spraying system, it is easy control. When you determine how much fertilizer is needed for the particular crop according to the crop health data, crop analytics, crop data we have, intelligent flight and autopilot modes can be selected according to real-time and environment data. So here, not only with the crop health and crop statistics, but also with the environmental data. What is the localized temperature? What is the wind speed? Whether it is favorable for the drone operation. So all those environmental data can also be customized. And if it is hand over to a farmer who is trained basically with the drone operation, these intelligent flight systems can warn the particular operator. It is non-favorable. The wind speed is not suitable to operate the drone as of now. So based on that, we can have easy control, adaptability. That is, it can be operated over mountains, hilly terrains, even without uh, uh, human intervention in highly wetted regions which are inaccessible one. Then foldable frames, easy to transport and versatile, maintenance, modularized design, cost control, and when we use these agriculture sprayers, it is already confirmed that we can save uh, plenty of water, and we can save excessive use of fertilizers. So it less water requirement for spraying activities, productivity increases, and when we are using these unmanned aerial systems for spraying activities, crop damage will be substantially reduced because of the reduction in the human movement inside the field, and it is uniformly applied over it. So all those things are very crucial advantages with the help of these IoT devices. Other roles of drones in agriculture can be improved with AI-driven technologies, soil analysis and field planning, seed pod planting, crop monitoring, pesticide spraying, irrigation planning. Irrigation planning is very crucial, and maybe while giving the application of drones, I will give more insights about this irrigation planning with the help of drones. Crop health assessment, I have explained with the banana farm crop health monitoring. Controlling weed, insect, pest and diseases. Even controlling the pest and insects also another advantage. It will make a specific irritating noise, and it is easy for us to control the insects from our farms. And tree crop biomass estimation, scaring birds. So scaring bats another one essential thing we need, especially in the case of agriculture. Then man-animal conflict also can be effectively handled with this is AI-driven drone technology. So these with these insights, the futuristic applications of now, as I mentioned, how data analytics play a crucial role with drone technology. Then, based on the different types of drones, how we have to plan our data analysis and hardware and the software part. Now I'm moving to how the bio-inspired drones going to transform this AI-driven drone technology. For example, if you consider a super hydrophobic surface, as I mentioned about lotus leaf, there are many surfaces which are not yet studied even. What is the surface morphology there? How it can be used in order to prepare a super hydrophobic surface, maybe which is suitable for a military garment, or maybe it is suitable for a military vehicle that can be camouflaged in a specific warfare. So it is not yet revealed most of the characteristics. For example, if you consider, I have classified these bio-inspired drones based on these four segments: super hydrophobic surfaces, lubricated surfaces, grooved circumference, and winged seats. Here you can see the surface morphology of rice and butterfly. This is the rice leaf surface. Here you can see the hydrophobicity nature. Here you can see the butterfly wing surface. So these surfaces exhibit, here you have a grooved nature grooves here. Here you can see a different scales here. So these surfaces naturally having the self-cleaning ability in nature. Now, if you want to prepare a drone, or if you want to prepare a surface with these abilities, you can customize this morphology with the help of the advanced polymers and materials, and you can arrive a waterproof drone, or you can have a unique application. For example, if you are able to make a uh, drone surface with chameleons nature, you can easily make invisible characteristics. Okay, it is maybe you can hear the noise of the particular propellers, but the drone may not be visible to you. So likewise, these bio-inspired technology can be adopted with drones through AI modules. You can collect these different samples, and you can use it for data analysis with your data analytics tools in AI. And those characteristics can be utilized for customizing your materials. So for those materials, those materials can be incorporated with your fixed wing drone or any specific kind of drone to achieve the end result. Though it is multidisciplinary, though it is challenging, there is plenty of scope involved with the involved in terms of research perspective in the next 5 to 10 years or whatever. Especially in the case of aquatic drones, it is capable to capture the underwater footage in seas and oceans. Especially, we can utilize it for surveillance purpose, whether there is any submarine or any abnormal movement inside the water. We can find the rare species of fish or any underwater mammals inside the waters. So aquatic drones are basically called as maritime robots that collect data autonomously and multi-use surface vessel with a wide range of sensors, autonomous operating system with object detection and avoidance. So these drones can be effectively utilized for uh, collecting the underwater data, particularly object detection and avoidance. Uh, Wide range of sensors can be utilized for identifying the depletion of the marine species because of the oil spillage and other various marine activities are spoiling the biodiversity in the oceans. So it is in terms of environmental protection perspective or in terms of security and defense perspective, these aquatic drones will be more helpful in the forthcoming years. Here you can see the underwater drones with the camera. Here also I have mentioned several types. You may Google it afterwards. Chasing Dory, chasing F1, and different types of drones and their battery life, diving depth, camera resolution, whether it is tethered or wireless. Mostly the underwater drones are tethered in nature because the underwater wireless communication is extremely difficult when it is go deeper, and the communication systems also expensive in nature, so mostly it is tethered in nature. Though it is tethered, more interesting data can be obtained through these drones. Here you can see chasing F1 fish finder drone. So these fish finder drones can be utilized to catch enhance your catch. So obviously it is very similar to the agriculture drones. It may transform the fisherman's life. So other side, we can, with the help of these AI-driven technologies, maybe the authorities and the companies who manage and maintain the assets in water can use these effective data to carry out the maintenance. And aquatic drones deliver the data processing and predictive maintenance model that fit the workflows with your hardware and software. So when you have, once you establish a complete data set, for example, in Bay of Bengal, in a specific region, this particular fish is there. In Arabian Sea, this particular fish is there in a particular region. So even the policymakers can advise in a particular month you can catch in this region, or in a particular month they can restrict the fishermen to protect the marine species in a particular period of time for their growth and other, in order to maintain the biodiversity and all. So this full data service is a possible solution through AI driven technologies only. So other optional systems and sensors very similar to our unmanned aerial vehicles. For underwater vehicles also, all these hardware optimizations and possibilities towards our research available. Here also the master hardware with a few components remains the same. You can make cosmetic changes and customize your system according to your requirement, according to the depth of the ocean where you are going to use the system. And the softwares, accordingly the sensors and the data transmission, in what fashion you are going to transmit your data and how you are going to process it, accordingly your system can be modified. Though I am giving a broader perspective in this presentation, you need to focus on a specific application with a particular drone with a specific cosmetic change, and accordingly you have to proceed. If you focus on this overview, it is practically impossible, and your lifetime is not enough to study the things. That much research and analysis contents available here. Okay, so that's why now people are working with BDM, that is so-called big data management tools, to handle these high volumes of data and to arrive the AI-driven solutions in optimal time. They are trying to integrate big data analytics with AI. So, as you know, when we talk about the aircraft, it is when it is moving from Chennai to New Delhi, there are thousands of sensors producing millions of data in the across the entire flight. when the engine was produced optimal fuel efficiency, when it was performing more efficient flight, that can be customized through this big data analytics. So from the data recorded over the segment of flight from Chennai to Delhi, we can easily customize what is the most optimal settings needed to have more efficient flight. In that way, we can utilize the big data analytics tools to customize our AI-driven drone technology also to achieve more prospective benefits. So here, this is the mobile-based applications which are utilized with autonomous underwater vehicles, and it is applicable to all types of fishing. And this is a sonar ball exclusive technology of the deeper helps to give the information which is under the water, and then it is emitted by the sonar waves. Then other marine species, particularly when you talk about the shark skin, you know, there is a denticles here. These dermal denticles has the potential to energize the vortices. So these flow over these riblets enhance the vortex mixing. So what happens is it reduces the drag. So based on this shark skin technology only, the company, Lufthansa Aviation, they have developed this surface artificially, and they have incorporated this thin film for their commercial fleet. You can Google it. This is called Aero Shark project, and their Lufthansa's cargo's entire Boeing 777F freighter fleet is incorporated with this drag reduction films. And after the implementation of this shark skin technology with their aircrafts, they have identified that there is around 3,700 tons of kerosene is saved. Obviously, it results with 11,700 tons of CO2 emissions, which is equivalent to 48 individual freight flights from Frankfurt to Shanghai. Imagine, with the help of a bio-inspired surface, how it is revolutionizing the aerospace sector. This is the shark skin based morphology here. So similar to shark, there are so many species available inside the ocean, and you can see these are the fish scale arrays we have studied in the recent times. So each of these fish scale has the unique capability to provide the drag reduction, better flow control over the surface. So if you use the aquatic drones, you may catch up with the more interesting features of all these marine species, and those specific unique features can be utilized with AI driven tools in order to customize your underwater vehicles to achieve better operational requirements, maybe with higher cruising speed, maybe with maybe the same technology can be utilized with your fixed wing drone. So there is a endless opportunity available with the bio-inspired drones. So since we have a limited time, I'm just moving it forward. Here you can see the drag reduction percentage. With the help of the riblet design, sawtooth riblet design, 8% turbulent drag reduction was achieved. And with the help of this sawtooth continuous design, 9%. And these are the references here. You can read all these references here. Though it is conventional references with traditional approach to study the drag reduction with bio-inspired surfaces, why I am illustrating the things is here you can the AUV autonomous underwater vehicles may enable us to identify more reliable and realistic features of marine species to have a real-time observations from the waters, and that can be effectively implemented with our drones directly. Because in those days, 1988, 1992, these AI and other advanced computing systems are not available now. So obviously, they were end up with restricted numerical analysis and experimental studies, and they are saying that 9%, 8% drag reduction. With the advent of the current technologies, it may be 18%, it may be 20%. Imagine around the globe, almost 80% of aerodynamists working with this drag reduction concepts, because even 1% drag reduction could save several thousands of liters of fuel. So it is a huge profit for the airliners, and even the tech giants are very much ready to invest with these technologies. So then it is for drones with AI software can be utilized for damage assessment, waste management. I will explain all those things in detail with the applications of drone side, and garbage management. As I told you, with mapping and tax collection segment, those who are involved with these unlawful practices of garbaging the streets, they can be those who are committing them, we can proceed with penalties and all those things with the help of drones with the AI enabled technologies and wind turbine inspection here. And this is what I have mentioned about these aquatic animals. Then, yes, the counter drone market solution. Here you can see uh, drone tracker and jammer, drone guard, drone dome, drone ranger, alert system. So all these different counter drone solutions provided by specific countries and specific category of applications are here. So detection and tracking, detection and jamming, so detection and spoof manual jamming. So each and every segment of these counter drone activities also having a specific research and fruitful market. That one also we should consider. We are always focusing on producing drones, utilizing it for a specific application. What about counter drone side? People are not focusing on the counter drone side. There is a huge market exists with these counter drone systems with AI solutions. Even in the case of counter drones with specific detection and jamming and destroying, AI is the only specific strategy to give better success rate. So the challenges involved as of now, the limited computational resources on board with the drones, battery life and weight constraints, and the most importantly, the privacy concerns in surveillance, regulatory compliance, and airspace management. In most of the countries, even regulatory policies are not yet developed for the usage of drones. So that is the real challenge associated with legal issues. And when there is an accident, who is going to pay the compensation and all those things? Now we have prepared a unique drone policy, and now mostly the drones are even agri drones are coming with third-party insurance and all. But in most of the regions around the globe, it is not yet established. So the future trends in AI-driven drones will be swarm intelligence for collaborative missions, integration with 5G and 6G for enhanced connectivity, use of edge AI for real-time decision making, enhanced safety protocols with AI-driven predictive maintenance. In summary, I can say AI going to transform the drones into versatile and more intelligent systems. It has the potential to revolutionize the industry and improve the human life. So explore AI-driven drone solutions for your specific department. Maybe you are from electrical engineering, computer science, aerospace, mechanical. Explore a most optimal AI-driven solution for your industry, and invest in future-ready technology. If you are an entrepreneur, you just try to invest with future-ready technology, because it is going to rule another 10 to 15 years without any doubts. So thank you for your serious attention, and Maybe if you have any questions, please post. Thank you.
Thank you, sir. It is always great to hear you, sir. Participants, if there is any questions, you can post in the chat box or you can unmute and ask directly to our resource person. So there is a question in the chat box, sir. How does the anti-drones differ with counter drone technology?
Yes, actually, the counter drones, as I have mentioned, that is, if you are preparing a AI-driven drone application, obviously it is involved with security issues, networking problem, and hacking issues, all those things. So, if you are preparing a lightweight cryptography-based algorithm or lightweight application to that can be incorporated with onboard drone systems, uh, this counter drone field, that is, you can use this. You can utilize the counter drone market to work with that. Whereas whereas it is your anti-drone, that is entirely different from this concept. It is a collection of tools or devices used to track, neutralize the drones that are unauthorized or malicious. So, anti-drones, specifically, if you are important for addressing the risk that drones pose to when it is operated in a sensitive area such as airports, military installations, those systems are basically anti-drones, whereas the counter drones are, as I mentioned, it is in the presentation here. You can see. Can you see the screen here?
No, sir, it is not visible.
Yeah, okay, no problem. No, it is manual jamming, detection and jam, detect and track. All those applications are coming under counter drone case. Hope you got the answer, right?
Yes, sir. There are a few more questions are there in chat box.
Tell navigation using AI with the help of video. As of now, it is not possible. Maybe you can get my email from the organizers. Definitely, I will share the link. Okay. However, it is in the development state only. Fully autonomous navigation is not yet established. But however, I will give you the navigation using AI, how it is evolving, and what exactly the roadmap I will share. What is the maximum battery life and time management for drones used in agriculture area? Battery life depends on your battery, what you are using. Maybe if you are using 25,000 mAh, for example, it will give around 20 minutes of endurance, particularly if you are using with 10 to 12 liters of can, which is incorporated with that. Hope you have seen the particular model with Garuda and other companies, those who are using with type certificate from DGCA. It is 20 minutes. And based on the amount of fertilizer you are carrying, maybe it is fully loaded or it is windy region. Based on that, your battery life may vary, and over the period also battery life will deteriorate. So based on that, only thing is you have to monitor the GCS. When you are operating the drone with the help of your mobile or laptop or whatever the ground control station, you have to monitor it, and based on the remaining battery, you have to take the quick decisions. So according to your question, I cannot say exactly maximum battery life for a particular drone is this much minutes. Then you will operate your drone for the particular time, and maybe local wind speed is more, and your drone will be spoiled. So that is the case. Okay. Hope I answered Mr. Palani correctly, right?
Yes, sir. There is one more question from Mr.
Rice
Anand.
yield prediction, sir. Your question is more AI driven. So, rice yield prediction. First of all, we need to identify what are the parameters that will enhance the rice yield, the parameters which are affecting the rice yield. So, accordingly, we have to develop a AI model. Then the model should be integrated with that. Then we have to identify the health of the rice leaves, health of the plant first. So whether it is healthy or it is having some vitamin deficiency or it is having some diseases, accordingly we have to use the fertilizers in a proper interval. We have to give water it properly, and based on those data, you may predict the yield with some 80% or 90% success rate. However, it is an intensive research subject. As I told the example for banana farm, maybe you can try with a paddy field. Okay. So that will help you in, that is a separate research work. Maybe you can do it as a PhD.
Yes, sir.
So
There is one more
just one
question.
more question. Yes, sir.
What is the relation between speed and payload of drones in a particular specified application? Sir, speed and payload, obviously both, when you increase the speed or you are operating the drone beyond the optimal speed, it will consume more battery. And if it is having excessive payload also, battery life is reduced. So there is a compromise. There is a balance between speed and payload. You have to consider the environmental conditions also, local wind speed, operating altitude, all those things. Then data transfer rate, how we are utilizing the auxiliary systems with that, all those things will determine. Maybe you can refer this velocity versus battery consumption trends with different literatures. That will help you with the specific type of drone. How do drones, farms, and machine learning evolve themselves coordinated task in this? This drones farming with unsupervised learning is the advanced part of AI-driven drone technology. So, unsupervised learning based drone technology itself a challenge right now. Now you are talking about the next level, unsupervised learning with swarm of drones. So let us establish first the unsupervised learning for the single drone, then we will move on to swarms. Okay. Sir, with the camera video of drone, can we do navigation with the help of AI? Navigation with the help of current AI tools, as of now, it is not available. And you are talking about autonomous flight, I think. So, complete autonomous flight is, as of now, it is not possible. Maybe you can check up with the DJI drones which are released right now, DJI Air 3 advanced and other later options. Maybe it is incorporated with some AI modules that may help you to capture the images according to the. It is enabled with the situational awareness mode. So if you enable the drone with a specific capture mode, it may give you the data. Okay. For example, if there is a water, if there is a pond, if there is a lake, instantly it has to capture the image like that. If you give the instruction, wherever water is there, it will capture the image. So that module is available right now, but I don't know how far it is allowed to import those advanced drones to India. So check up with that. Okay.
I think there is no more questions, sir.
Okay.
Shall we conclude, sir?
Yeah, no problem. Thank you.
Yes, sir.
Any,
Thank you, sir. Thank you so much, sir. Thank you for your valuable time and insight, sir. We'll be connecting in the session for applications of drone. So probably we
sure,
can discuss more on applications.
sure,
Thank
sure,
you,
sir.
sir.
Thank
Thank you so
thank
much, sir. Thank
thank
you.
Bye. Bye.
Thank you,
Good.
Dr. Bruce. Thank you.
Thank you, participants, for your valuable time. And we are closing now. Tomorrow we'll be joining by 6 p.m. And tomorrow we plan for 2 more sessions. Thank you all. You can leave. Thank you.